one step closer to answering the age-old question, are we alone in the universe?
Proxima Centauri b, the closest exoplanet to our solar system, has captivated the imagination of scientists and space enthusiasts alike. This video delves into the fascinating question of whether life could exist on this potentially habitable world, exploring the challenges and possibilities that this intriguing planet presents. The closest exoplanet to Earth, a super-Earth, slightly larger than our planet, orbiting the red dwarf star, Proxima Centauri. For a really long time, individuals have imagined what life may be like in other universes because of the James Webb Space Telescope, the most astounding telescope in existence. That question can finally be examined while seeing the closest star system to us, Proxima Centauri, which is only 4 light-years away. Scientists have observed a couple of outstanding peculiarities from one of the planets in the system. Proxima b, these quirks called artificial lights have confounded the best minds in the field of science anyway. What are they? Do these lights propose the presence of smart life? Join us as we examine the James Webb Space Telescope's disturbing discovery of city lights that could change everything. The main life that we are currently aware of is on Earth since the beginning of human development. Individuals have questioned whether there is life elsewhere in the universe to complete such an interstellar search. American cosmologists Jill Terrar and Thomas Pearson launched the Search for Extraterrestrial Intelligence SAIDI project in 1984. The beneficent objective was to gather space-borne radio transmissions. Radio waves can travel farther and are thus more likely to be identified by the 42 radio telescopes that make up the outstanding Allen Telescope Array in the Californian foothill mountains. However, before 30 years ago, no conspicuous extraterrestrial signals had been tracked down. Following that, the James Webb Space Telescope's successful launch helped the journey to check a degree of inconspicuous planets orbiting faraway stars as the largest telescope on the planet, floating around 1 million miles from Earth, and outfitted with exceedingly sensitive pointers. It has the potential to uncover colossal discoveries. 20 years ago, there were no known planets outside our planetary system. However, since then, more than 4,000 exoplanets have been found orbiting various stars. As demonstrated by NASA, the universe might contain trillions of exoplanets. The earliest signs of something happening deep down past our planetary group may be viewed as extraterrestrial vegetation. The Galileo spacecraft on its course to Jupiter turned its instruments back. The Goldilocks Zone. Is Proxima b in the habitable zone? The challenges of life around a red dwarf star and the potential for liquid water and atmospheric conditions. Toward Earth and saw an obvious indicator of the presence of plants, recognizing the vegetation. Red edge, a biosignature, a mix of red and infrared light reflected by plants. For instance, a planet like Earth covered in a wild should have a large area of strong signature, easily recognizable. The JWist will measure the VRE of faraway Earth-like planets in the habitable zone around stars, which could give significant signs of something happening on a deeper level in the exoplanet's atmosphere. When daylight crosses a planet's star, the JWist may have the option to distinguish it as it enters its atmosphere. The missing frequencies would then be observed through spectroscopy as particles and atoms in the air absorb specific frequencies, creating a characteristic fingerprint that the JWST can recognize. This method may be used to determine the composition of the atmosphere and whether life is possible. Life could exist on Earth-sized planets with atmospheres like our own, characterized by a mix of oxygen, nitrogen, and carbon dioxide. By looking for elements that aren't typically the use of telescopes and space probes, the challenges of interstellar travel and observation, and the potential for future missions. Present one could potentially recognize intelligent life. For example, chlorofluorocarbons, CFCs, created for use in refrigeration and cleaning products, would very likely be detectable to outsiders examining Earth's air from a remote location. If the JWST finds CFCs in planetary atmospheres, it could indicate the presence of life. However, life on exoplanets probably won't resemble life on Earth in any way. Sometimes even normal living things like extremophile species that can survive in conditions where other living things would die can appear alien. This group of life forms, mostly microorganisms, can endure extreme conditions such as temperatures up to 250 degrees Fa or strong acid with pH levels under 3. Since planets like Earth are more likely to support life than those with extreme temperatures or acidic conditions, it could be wise to begin with. Those first prime candidates could have temperatures that allow liquid water to exist on their surfaces and orbit a stable star. Our Sun is a yellow G-type star. These stars are rarer and typically have shorter life expectancies. However, in our universe, the likelihood of finding planets orbiting red dwarf stars, which are more common, cooler, and dimmer than our Sun, is higher. This long time span allows for the development of life and evolution to produce complex organisms around 40 light-years from Earth, the TRAPPIST. One planetary system will be the subject of the JWST first mission. It orbits a Cal red dwarf star with 7 Earth-sized rocky planets. 3 of these rocky planets, located in the so-called habitable zone, could have the potential for life on Proxima b. The implications of discovering life on another planet. The future of exoplanet exploration. Liquid water on their surfaces despite its smaller and colder mass compared to our Sun. The TRAPPIST-1 star emits light similar to Earth's due to the close orbit of its planets. The most obvious opportunity to observe city lights outside the nearby planetary system is Proxima Centauri, a red dwarf star that is 4.25 light-years away from the Sun. Proxima is many times fainter than the Sun, so a planet would have to be much closer to it than Earth is to the Sun to support life based on liquid water. In August 2016, astronomers found a planet with 1.3 Earth masses in this habitable zone, a Goldilocks-like zone where the light intensity is just right for melting water. Proxima b orbits Proxima Centauri, but the fact that Proxima b is tidally locked makes it a potentially airless dead planet since it orbits its red dwarf star just 4.6 million mil away. This close orbit exposes it to strong solar winds that can strip away its atmosphere. However, Proxima b receives enough light for temperatures and liquid water similar to those on Earth because of its proximity to the star. Proxima b is believed to be tidally locked, meaning it always shows the same side to the star, much like the Moon does relative to Earth. Proxima Centauri is around 18% the mass of the Sun and radiates significantly less light than one might expect for a planet so close to the star. Just about 5% of the Sun's power could seem like a bar wasteland, but liquid water could exist on Proxima b if the planet has an atmosphere to retain heat. Since the total energy reaching it from the Sun is only 65% of what Earth gets, the planet isn't particularly conducive to life. It is likely tidally locked, meaning it always faces the same direction toward the star, creating a permanently hot side and a cold dark side with extreme temperature variations. The planet also receives 100 times the amount of high-energy radiation as Earth does, including X-rays and ultraviolet light due to its proximity to Proxima Centauri. Proxima b is also bombarded with high-energy particles during star flares unless it has a protective magnetic field. Like Earth's conditions may not be favorable for life. Despite these harsh conditions, Proxima b may still be a more habitable world. Unfortunately, models suggest that the atmospheres of tidally locked planets may be prone to fast deterioration due to the freezing out of volatile gases on the night side. Our planet's atmosphere can be replenished by volcanic activity, and for planets. Summarize the key points about Proxima b. Reflect on the possibilities of finding life beyond Earth. The excitement of exploring the universe and our place in it. With strong magnetic fields, their atmospheres are less likely to escape. Since we don't know anything about Proxima b's volcanic activity or magnetic field strength, we can't even guess whether the planet has an atmosphere. However, since an atmosphere suggests the possibility of life, we are eager to know if Proxima b has one. It could have solar panels covering the day side to generate power to light, and form the night side, which would otherwise be too cold and dark for habitation. The discovery of Proxima b has triggered a race to determine whether it crosses its star's face as seen from Earth. These transits would allow scientists to determine the planet's size and mass, which would help them estimate its density and confirm its rocky composition, providing information on the materials used to form those rocks during a transit. Starlight could reveal the nature of the planet by passing through its atmosphere. However, the likelihood that the orbit will be aligned perfectly so that scientists can observe a transit is just 1.5%. The star's tendency to flare up further complicates matters. Astronomer David Kipping of Columbia University says the star is unstable as stellar heat causes a rocky planet to absorb sunlight and write it as infrared light. However, rocky planets produce a distinct type of infrared radiation from stars like Proxima Centauri. Additionally, the James Webb Space Telescope scope was specifically designed to observe infrared light. Proxima b's infrared signature is crucial for identifying the planet's atmosphere. Moreover, the infrared capability of the JWST, which surpasses the Hubble Space Telescope, could allow it to detect city lights on the night side of the planet, even if they are as weak as those currently used on Earth. the JWST could detect artificial lighting as long as it is limited to a frequency band much smaller than the star's light. Proxima B's day side may be heavily covered with solar panels reflecting starlight as Proxima B orbits its star continuously. The day and night sides are very different with extreme temperature differences between them. The temperature difference between day and night depends on whether the planet is made entirely of exposed rock or whether air and water circulate heat. If there is no atmosphere, Proxima B's day side and night side temperatures will vary more since the day side will emit all the energy it receives from Proxima Centauri as a black body. The night side would seem like a frozen wasteland. If the temperature difference between day and night is less pronounced, we can speculate that future space exploration and the search for life beyond Earth hold massive promise. The James Webb Space Telescope JWST may be the key to discovering extraterrestrial life in the universe. As the JWST seeks out exoplanets, it will ultimately help shape our understanding of other worlds and our own. The search for extraterrestrial real life has taken a monumental step forward with the capabilities of the James Webb Space Telescope. While we have only begun to scratch the surface of what it can teach us about planets in distant star systems, the discoveries made so far offer tantalizing glimpses of what could be out there as we continue to observe exoplanets like Proxima b and others in the TRAPPIST-1 system. The potential to detect life, or at least signs that life once existed, grows stronger. Even if these planets do not currently harbor life, their study will help us understand the conditions necessary for life to thrive. Every new discovery adds another piece to the puzzle of how life could emerge in the universe. In addition to looking for biosignatures like the vegetation red edge or atmospheric components such as CFC, scientists are also investigating more subtle signs. Artificial lights, for example, may not be the only indicator of intelligent life. Variations in the planet's radiation or unexpected patterns in the magnetic field could also signal something more than a natural environment. Identify and study these anomalies will provide a wealth of information about the potential for life beyond our solar system. The possibility of intelligent life existing somewhere in the universe remains one of humanity's greatest questions. The discovery of something as complex as city lights on a distant planet would be a game changer in the search for extraterrestrial civilizations. Even if the evidence is circumstantial or indirect, it would prompt a re-evaluation of the uniqueness of life on Earth and the potential for other civilizations to have developed in far-flung corners of the cosmos. Looking ahead, the JWST role in uncovering the secrets of distant planets is invaluable. Its ability to observe exoplanets in greater detail than ever before, particularly in the infrared spectrum, will allow us to analyze the atmosphere's compositions and even potential signs of life on planets light years away with its unparalleled precision and sensitivity. It may be only a matter of time before the telescope detects something truly groundbreaking that confirms the presence of life elsewhere. As scientists continue to monitor planets like Proxima b and explore the possibilities of habitability, we are on the verge of potentially rewriting the story of life in the universe. The era of space exploration and extraterrestrial discovery has only just begun, and the JWST will be at the forefront, guiding humanity toward new frontiers of knowledge and understanding. In the end, whether we find artificial lights, biosignatures, or other telltale signs of life, the pursuit of these discoveries enriches our understanding of the universe and our place within it. The search for life beyond Earth is not just about finding others, it's about learning more about ourselves and the incredible complexity of the cosmos. Through the eyes of the James Webb Space Telescope, we may soon answer one of humanity's most profound questions: are we truly alone